Okay, so we've talked about how to find the domain of a rational expression. Our next job is talking about simplification. How do we actually simplify a rational expression? And I think to explore that, it's kind of helpful to look at two expressions and just compare what's going to happen. And what I've done is I've looked at these two expressions, x squared minus 25 over x squared plus 13x plus 40 versus x minus 5 over x plus 8, which you might already suspect something about here. But let's do this anyways. Let's evaluate them. Let's evaluate these two expressions at numbers like x equals negative 2 or x equals negative 1, x equals 0, x equals 1, and x equals 2, just to see what's going to happen. Because I think it illustrates a pretty interesting point. All right, so let's take this at negative 2. Let's see, our expression here at negative 2. I'm just going to do some work off to the side here. Don't mind me. Let's see, at negative 2, I'm going to get 4 minus 25, right? Negative 2 squared is positive 4, divided by negative 2 squared, that's 4, plus 13 times negative 2, so that's going to be minus 26 plus 40. So when I work through that number, that's going to give me, let's see, negative 21 divided by, let's see, 4 minus 26 is negative 22 from 40. Negative 22 from 40 would be 18, right? So if we reduce that down, we're going to find that our value here at x equals negative 2 is reduced by dividing by 3, negative 7, 6. All right, what happens right over here? Well, if we try it with x minus 5, right, at x equals negative 2, we find that we get negative 2 minus 5 divided by negative 2 plus 8, which is to say negative 7 divided by 6. Lo and behold, it's the same value. Negative 7, 6. So, you say, and that's kind of interesting. Let's try it one more time. Let's try it at x equals negative 1. X equals negative 1 is going to give us negative 1 squared. So that's 1 minus 25. And let's see, negative 1 squared is 1 again, plus 13 times negative 1, so minus 13 plus 40. Let's see how this one works out here. That's going to be the same thing as negative 24 in the numerator. And just doing some quick arithmetic, negative 12 plus 40 is going to be 28 in the denominator, and those are both divisible by 4. And it looks like that should reduce. So let's see, at x equals negative 1, I'm going to get a negative number again. Divided by 4, that's 6. Divided by 4, that's 7. All right, well, let's try this guy right over here. What happens at x equals negative 1? Well, we're going to get negative 1 minus 5 divided by negative 1 plus 8. And let's see, that looks like a negative 6 in the numerator. And sure enough, a 7 in the denominator, and so it is negative 6/7 here. 0, that should be an easy one, right? If you take 0 squared minus 25, that's minus 25. So at x equals 0, we're going to try x equals 0. We're going to get 0 minus 25 divided by 0 plus 0, 13 times 0, 0, plus 40. So 25 and 40 both share a common factor of 5. So divide by 5, that's negative 5. Divide the denominator by 5, that's 8. And sure enough, if I put in 0 right here, that's an easy one, right? Negative 5 over 8. So what do you suspect is going on here? Well, the same thing that I suspect is going on is the fact that this expression is the same value of y for every single value of x that you substitute in. So I worked out the rest of these ones, of course. Hopefully you might have paused and tried it out yourself. If you want to pause right now, go ahead. When I substituted in x equals 1, of course, I got the number 24/54 over here, which reduced to -4/9. And sure enough, if you substitute in 1 into our other expression, you get -4/9. And if you substitute in x equals 2, you have let's see, where we get 21/70, which reduces to -3/10. And of course, that's exactly what we get if we substitute in over here, -3/10. So it looks like our expression is exactly the same for all of these values. And this should point out to you one thing, and the main point is that it is the same function, with the exception of a single value. And what we would do right here is on the left-hand side, we actually have a trinomial that we can simplify. And we simplify by looking for common factors. So in other words, what we have to do if we're going to simplify this guy is to factor. And that's always your first step when it comes to dealing with these trinomials. So we're going to factor. And then if you recall factoring here, that should be a factor with an exclamation point after it. So we're going to factor. Well, in the numerator, we've got x squared minus 25, which is x plus 5 times x minus 5. As you remember, there is a difference of 2 squares. And in the denominator, we factor this out. We get 2 binomials starting with x. Let's see, 40 factors into 2 factors, 8 and 5, whose sum is 13. So plus 8 and plus 5. And these factors right here would cancel out, giving us x minus 5 over x plus 8. And the only place where these two expressions is not going to equal is where x is not equal to -5, right? Because if we try substituting in -5 right here, we get an undefined. And we don't want that, even though in the reduced expression, we don't get a 0 in the denominator. In order for both expressions to be completely equal, they have to be equal everywhere except at -5. So our simplified expression would simply be x minus 5 over x plus 8, as long as x is not equal to -5. In the next video.